So this one, our topic for this afternoon is the naive Bayes classifier. So we have this technique in data analysis called prediction and classification. When we say classification, those are the technique that is used to predict group membership for data instances. So it will be predicting the class of one particular record. And this classification and prediction are two forms of data analysis that can be used to extract models describing important data classes or to predict future data trends. Classification predicts categorical labels. When we say categorical labels, those pertains to the class of a certain record. For example, it can be in category A, category B, or so on. So basically, in classification, we predict the record according to its category. Whereas prediction models continuous valued functions. So in prediction, we will be predicting the values, specific value. So classification is the task of generalizing known structure to apply to new data. So here are the different methods in prediction and classification. We have multiple linear regression, KNN, naive Bayes, regression trees, logistic regression, and neural networks, and some other ensemble techniques. So what we are covering today is the naive Bayes, since multiple linear regression and KNN are pretty basic, so we're gonna proceed to naive Bayes. So the naive Bayes, here we will be introducing the naive Bayes classifier, which can be applied to data with categorical predictors, and we review the concept of conditional probabilities, then present the complete or exact Bayesian classifier. The steps that basically involved in naive Bayes are: first, it will find all the other records of the same predictor profile, example where the predictor values are the same. Second, it will determine what classes the records belong to and which class is most prevalent. 3, it will assign that class to the new record. So the naive Bayes method, and indeed an entire branch of statistics, is named after the Reverend Thomas Bayes from 1702 to 1761. To understand the naive Bayes classifier, we first look at the complete or exact Bayesian classifier, and the basic principle is simple. For each record to be classified, we have to follow the 3 steps that we mentioned earlier. So here we have an example of predicting fraudulent financial reports using 2 predictors. Assuming we have these records consisting of, or this is the data set consisting of 10 records, and each record is a company and their record according to whether they have prior legal trouble or their company size, and the status truthful or fraudulent. So this is an example of a financial report, and we will have 2 predictors that we'll be using here for classification, and that are those are the prior legal trouble and the company size, and the status will be the outcome that we want to predict. this will be the class that we want to predict. So that is why this is called a classification, because there are two classes, truthful or fraudulent. So we will try to predict whether one company that is an applicant company is truthful or fraudulent based on two predictors: prior legal trouble and company size. So we have here a very small subset of data, and then we will be using the naive Bayes classification to accomplish our classification task. Here in table 8.2, we have, for each customer, we have information on whether it had prior legal trouble, whether it is a small or large company, and whether the financial report was found to be fraudulent or truthful. So this status pertains to their financial report. And using this information, we will calculate the conditional probability of fraud given each of the four possible combinations. Y small, Y pertains to yes, whether they have prior legal trouble, and small is the company size. Then the second possible combination is they have prior legal trouble and the company size is large. Then there is no prior legal trouble and the company size is small. And then there's no prior legal trouble and the company size is large. So these are basically the possible combinations of the values of our two predictors: prior legal trouble and company size. So using the complete exact Bayes calculation, this is the traditional probability computation. So we will have to get the probability of each combinations, okay, according to, so these are, for example, the first one is we have the probability of fraudulent financial report if the prior legal value is yes and the company size is small, and that is equals this to get the probability of its fraudulent, that company is fraudulent, is we have 1 over 2 equals 0.5. One fraudulent out of 2 records whose prior legal is yes and company size is small. So looking at our data set here, yes and small, this is what we're looking for. This is only one. Okay, only one yes and small, only one yes and small, only one company whose prior legal trouble is yes and company size is small, that is fraudulent, out of 2 companies whose prior legal is yes and the company size is small. Ang isa is truthful, di ara. Ang ikaduha is truthful. So the probability is only 1 over 2. And that is equals to 0.5. The next is the prior legal is Y and the company size is large. So, pila ka buok sila. This is yes, where's yes and large is duha. Okay? And all 2 of them is fraudulent. So that is 2 over 2 equals 1. Next is prior legal is no and the size is small. So we have 1, which is truthful, and the second is truthful, and the third is truthful, and then no other records for N and small. So that is 0 out of 3, because all of those 3 are truthful. There are 0 fraudulent out of 3, prior legal is no, and size is small. So that is equals to 0. The fourth one is prior legal is no and the size is large. So we have 1 is truthful, the second is truthful, and the third one is fraudulent. So only 1 out of 3 companies whose prior legal is no and size is large. So that is equals to 0.33. So based on these calculations, we can therefore say that there is higher probability of fraudulent financial reports if the prior legal of that company is yes, means that they have previous legal violations or record, and their company size is large. Now, in using naive Bayes calculation, we compute the naive Bayes probabilities. So, for the conditional probability of fraudulent behaviors given prior legal equals yes and size equals to small, the numerator is a multiplication of the proportion. So, we'll have to again compute for the naive Bayes for each of these combinations. Okay, sa upat. But this time, we'll be using the naive Bayes formula. The previous one is the traditional probability computation. This time, we'll be using the naive Bayes. So, to get the naive Bayes is you'll have to get the numerator, and the numerator is the multiplication of the proportion of prior legal, which is y. That is the instances, and among the fraudulent companies times the proportion of size is small among the fraudulent companies, and times that you multiply to the proportion of fraudulent companies. So that means this will be the numerator of the calculation. 3/4 is the proportion of the yes or the prior legal equals to yes among, this is among the fraudulent companies. So there are 4 fraudulent companies. Have here there are 4, and in this 4 fraudulent companies we have 3 yes. So we have 3/4. And then for the small, or for the second numerator is the size is small. So here, for out of 4, there is only 1 small. So 1/4. And then the next is, this is the number of fraudulent companies all over the number of companies. So this one is 4 fraudulent companies out of 10. 4 out of 10. So that is equals to 0.075. And to get the actual probabilities, we must also compute the numerator for the conditional probability of truthful behaviors given the prior legal equals to y and the size equals to small. That's our first combination, and that is 1/6. This is for the truthful. So before we have, this is based on the fraudulent, this will be based on the truthful. So there is 1 yes, out of 6 truthful companies, and then there is 4 small company size out of 6 truthful. So that is 1, 2, 3, 4. 4 out of 6. So 4 small and out of 6, and there are 6 truthful out of 10. So this is equals to 0.067. So the denominator is then the sum of those two conditional probabilities. So we have this conditional probability for the fraudulent, and the second conditional probability is for the truthful, and we'll have to use this in our formula for the naive Bayes classifier or probability. The numerator will be your conditional probability for fraudulent behaviors, and then all over the fraudulent conditional probability plus the truthful conditional probabilities. Okay, so this is your conditional probability for fraudulent, and then all over the two of those conditional probabilities, the sum of the two. So that is equals to 0.53. Then for the prior legal is yes, and for the size is large, these are their conditional probabilities using the same formula that we did here. But of course, they'll have different values for each of the numerator and denominator. So here, using the naive-based conditional probabilities here, we can also therefore conclude that this combination the company whose prior legal is yes and the size is large has the highest probability of giving us fraudulent financial report. Next, we have example. Another example is this will be predicting delayed flights, and this is actually a larger numerical example. So imagine going through all the records. In our previous example, we only have 10 records, and of course in reality our records or the data sets will have more than 10 records. So you'll need to have a software to calculate automatically all of these calculations. By the way, the step-by-step process of this calculation is discussed in more detail in your other subject, which is the data mining subject. But in our case, we'll be dealing with how you would apply those steps using big or larger records, or what we call big data. Wow, salamat. So here we have, again, our focus here is to use the tools for us to calculate, for us to get our outcome, and at least will not be calculating all the records manually. So we'll be using the second example, which is now this will have more than 10 records na maybe 1,000 records. So this is predicting delayed flights. So predicting flight delays can be useful to a variety of organizations, airport authorities, airlines, and aviation authorities. At times, joint task forces have been formed to address the problem. If such an organization were to provide ongoing real-time assistance with flight delays, it would benefit from some advance notice about flights that are likely to be delayed. So here in table 8.3 are the description of the variables for flight delays example. When you say the variables, those are sometimes we call it the predictors, or actually the selected columns of our data set. So in this data set, the outcome of interest is whether or not the flight is delayed. So the class that we are predicting in this data set is delayed or on time. Delayed here means the aircraft arrived more than 15 minutes late. Our data consists of all flights from the Washington, D.C. area into the New York City area during January 2004. And the record is a particular flight. A record means isa ka row. Okay? The percentage of delayed flights among these 2,201 flights is 19.5%, and the data were obtained from the Bureau of Transportation Statistics. The goal is to accurately predict whether or not a new flight will be delayed. The outcome is 1 delayed, 0 on time. So our approach here is we'll have to partition. If we are using a naive-based classifier, we will partition our data set into 60% for training and 40% for validation sets. When we say training data set, those are what we will feed into our classifier. And the validation sets will be the records that we would predict. And then a naive-based classifier was applied to the training set. So in using R, we'll need the library called E1071 so that we can use the naive-based function or library. So again, these are the variables that are chosen as predictors of the flight status, whether it's delayed or on time. So we have the day of the week. Of course, this variable is a contributing factor. If it's Monday, of course, the people are busy or sometimes people are lazy. It can be a contributing factor whether the flight is delayed or not. So the values of this attribute are 1 means Monday and 2 is Tuesday up to 7, which is the day of the flight is Sunday. Then we also have the schedule of departure time. So it is broken down into 18 intervals between 6 a.m. and 10 p.m. We also have the origin, 3 airport codes, the DCA, the IAD, and the BWI. These are the origin of the flight. Okay, the airport codes. Then destination, so these are JFK for Kennedy, LGA, EWR, so also 3 destination. And carrier, these are the aircrafts, CO, DH, Delta, DL, MQ, OH, RU, UA, and US. So, walay Cebu Pacific diri, kay sa kuan man ni siya, international. So, the first part of the output in table 8.4 shows the ratios of delayed flights and on-time flights in the training set. This is what we call the a priori probabilities, or sometimes called the pivot table. So this will be the output of the this is the priori probabilities. This will be the output of our scripts. So this will be automatically computed using some R scripts, as well as the conditional probabilities of each. So remember, a while ago we computed the conditional probabilities of each variables. So if you do it manually, you would consume a lot of time, and maybe you will finish it in years. So going back to classify a new flight, we compute the probability that it will be delayed and the probability that it will be on time. So kanina, we only have two predictors. This time, we'll have how many predictors? There are, I think, four. The carrier, the day, week, the departure time, the destination, and the origin. So, five predictors. So, imagine calculating that five predictors. So, you will really have you would have a hard time in calculating those probabilities. So, to recall that since both will have the same denominator, we can just compare the numerators. And let us use an example to classify a Delta flight from DZA to LGA departing between 10 a.m. and 11 a.m. on Sunday. We first compute the numerators. So, this one, if we are classifying this particular record, this will be our formula. Okay, if we use the previous example, this is the same formula. But this time, we'll not be using that since we already have a software that will help us accomplish this task. But if you calculate it manually, you would get this 0.0019 conditional probability of this values that it will give us an outcome of delayed. And on time, the probability of on time is 0.00029. This is just for the numerator. Kanina, we have the numerator part. This is just for the numerator part. And looking at the numerator, we can see that it is higher. There's a higher probability that this values will give us a classification of on time. We can predict that given this value, it will be it will give us a flight status of on time. So we use this symbol, meaning this is proportional to, because it's not yet finished. This is just for the numerator, but it can still give us the outcome by looking at it by the use of the numerator only. Now we'll be using how do we compute those conditional probabilities for our variables. So of course you'll have to use, this time I'm using the RStudio. So this is a more this is also R, but it's an IDE. It's more graphically illustrated environment of R. So what we'll do here is first you'll have to set up your path. So we'll make a path I will share it again. This is our IDE, VR Studio, and then we'll have to set the path, the working directory. So let's choose a directory. So I'm gonna save this in drive D, and I'll make a new folder here. What This is February 3, 2021. And I'll have to save my data set here. So the data sets are in my R tests. I'll have to copy that data set first. So I now have my data set in this folder, in this folder. So this will be the directory where we're gonna save our R script. You can use R, the classic R that we used previously, or you can also use this one, R Studio. But this is more interactive environment. So what we're gonna use is again the library E1071. If you don't have the library, this library installed, you'll have to use the install packages. E1071 before you can use this library. So since I already have installed this, I will skip installing. I will directly use library, the library command to use the library E1071. And then next to that, we'll have to create a data frame that will store all of the data in our data set. This is flight delays.csv. So let me share to you our data set first. So this is our data, the flight delays data set. Then these are their column names. The CRS departure time, the carrier departure time, the destination, the distance, the flight date, flight number, origin, the weather, the day of the week, the day of month, then the tail number, and the flight status. Okay. it actually has, let me see, it has 2,201 records. Now going back to our R, so we want to read our data set and store it in our um, in this container called delays.df. So you would see here the data that we created, delays.df. And you can also double click here to see what's inside of this. Delays.df will contain all the data of our data set. So it just copies all of those data. It has 2,201 records. So this is the data of delays.df. And next we have to convert all of the numerical variables to categorical. So we have the day of the week. Where is it? The day of the week, we'll need to convert this into categorical. So we see it's a numerical value, but we want it to be used as a category, because one here pertains to the value Monday, 2 is Tuesday, 3 is Wednesday, and so on. So it's a category. So to create a category or to change the variable into category, you will be using the factor function. And then you'll just have to pass inside the specific name of the column. Then after the day of the week, we'll have the departure time. You also have to convert it to... Salamat kuya, napagyoy sobra ya. Tama na na iya oy. Grabe di si kuya palangga gid kay ko. Departure time. Okay na iya. Ano? Factor, tapos delays that df, sorry, kusabon ako, delays at df, and then you have to specify the department time. Next, we also have to convert the of course the flight status is our outcome, so you also have to convert that to category. So that is flight status delays.pf. And then we also have to change the CRS departure time. But this one we'll need to convert this to, or to round the values of this, and multiply it to, or divide it to 100. That is by the use of a round function, and then delays.df, then specify again. That is, you divide it to 100 and then round. Take note of the values here of the CRS departure time after we change the value being rounded. So you see here, this was 1455 before, now it's rounded to 15, and this 1640 divided by 116. So because we want to get the time, okay, and then kanina 1455 means that is the time is 14 in hour and 55 in minutes. We want to get only the hour. That's why we have to divide it to 100 and then round it. So the 1455, you round it to 15. It's now 15. Its nearest is 15. The 255 is nearest to 3 o'clock. So that is 15. 1640 is 16, and 1245, and so on. Then we have next is, we will be creating the training and validation sets. So we'll have to create the variables. We'll select the variable in our data set, and we want to select only those that we think that are highly attributed to the status of the flight. So in data mining or in data analysis, we need to analyze each of the column names, whether we will use those in the analysis or whether we'll discard them. So here, we will select only the column 10, the column 1, column 8, 4, 2, and 13. And those are, column 10 is, this CRS departure time is 1. This is 1, this is 2, 3, 4, 5, 6, 7, 8, 9, 10. So we are selecting only, we will be selecting this for our analysis, the day of the week. 10 refers, the column 10 is the day of the week column. So we'll select it as our variable. And then 1 is the CRS departure time. 8 is the origin. And 4 is the destination. 2 is the carrier. And 13 is our outcome, the class, on time or delayed. That's the flight status. So these are the only variables that we will include in our analysis. And then we have, next to that is, we'll have to create the index. So we will be using here the sample function. Delays.df 1. Okay. So here we are creating the the train dot index. Okay, so in creating our training data set, you also have to specify the indices. So for example, we have this data. I will be using the previous one, a smaller number of records to show our to illustrate the R script. So dito ganina no, train that index sample, this is a function, and then we create here, we assign or send to function first argument and a second argument. So the sample function is what we use to create random numbers. Okay, we use the function sample to give us a random numbers. So this will be based on the elements that we passed in this function. So the first here is that we have the um, the the numbers from 1 to the dim delays df at 1. So let me copy this first to my Jamboard. Hindi siya makopy. Saan mo siya pag-copy? Paste. So this is our command. I will copy again. So assuming that we only have this one, let me use this short and small data set for illustration purposes. So the 1 to dim here, C is what we use, a function that we use to generate a number, usually in a range. So for example, if you set here 1 to 10, example, if you have C 1 to 10, okay, then it will give us numbers from 1 to 10. Okay, so but the second one, instead of 10, we used here the dim delays 1. So the dim is another function that we can actually use to create or to access the dimension of a specific value. So this time, the dimension of the delays.df. Okay, this is the dimension of delays.df, and we set the number 1 here in the in the dimension. So for example, you have the what's my example, Annie? Example is if we have actually kanina lang itong gamiton. Delays.df, for example, the delays.df is this data set. Okay, so the dimension is actually the number of rows and the number of columns. So this is, the rows is 10 and the columns is 4 here. So the dimension is 10 by 4. And if you want to get the number of rows, you'll have to specify 1 here. Okay? If you want to get the number of columns, then you'll have to specify 2. Okay? So, this actually means that we have to get the number of records. Dim delays the TF means this will give us the number of records, the number of rows. No? The number of rows. This example, the number of rows is 10. So, this basically is equivalent to 1. Asa man ang kuana ni? Say color ni. Color. Okay. So, using this data set, okay, so this is 10. So, this is the same with 1 to 10. No? It will give us the values 1 to 10. So, this is the first argument of the sample, and the second argument is the number of rows. This function will get the number of rows of our data frame. In this example, 10. But of course, in our code here, we are dealing with the 2,201 rows. So, in this example, we have 10. So, that is 10 times 0.6, or basically, we want to get the 60% of the number of rows. So, here, we'll have the 60% is 6. Anong delay man siya? Okay. So this will give us 60%. So 6 numbers. If you use the sample function, it will give us a random number from 1 to 10. If there are 10 records, 10 rows, it will give us a random number from 1 to 10, but it will give us only 6 random values. So it can be 2 from 1 to 10. It can be 2, 4, randomly selected na siya. 2, 4, 3, 8. Kadugay pa rin niya mag-type po eh. 7. So, pila na kabuok? 5 pa kabuok. Pila na tuog? 9. So, 6 kabuok. That is 60% of 10, or the number of records. 10 is the number of records. So, 60% of that is 6. So, sample will give us random numbers specified in the first argument, and the number of random numbers is specified in the second argument. Now, this is just assuming, because this will not always be the case that it will give us this values, because it's random gani siya, no? So, depende siya kung unsa iyahang ihatag. Randomly generated number 6. This is in this 10 records. Now, if you have 2,201 records, it will give us how many records? How many random numbers? Anybody? Kung 10 kabuok ang atong records, it will give us 6 random numbers. Okay, 60% of 10. This is 10. Okay, 10 records. 60% is 6. 6 random numbers from 1 to 10. The values are 1 to 10. Now, here, The delays that TF here is 2,201. So what is the 60% of 2,201? Naapa mo dira, guys?
Yes, ma'am.
Yes, ma'am.
1,200, ma'am.
Ano, ma'am? 1,320.6? Tama ba?
1,200, ma'am.
Later.
Kuan, ma'am, 1,320.6.
Okay.
Nice one.
1,320. Okay. Whole number. Kay number of, kuan man ni siya, number of
Ito.
random numbers. So, the integer is 1,320. That's 60% of 2,201.
Yes,
And
ma'am.
then, unsa man na iyang ihatag nga random numbers, wala ta kabalo kay random man siya. From 1 to 2,000, this is from 1 to 2,201. Okay? But you can actually see the result. Unsa iyang gihatag nga random numbers diri sa value ni train.index diri o. You can use the view command train.index. So, mo ni ang mga random numbers, pila ka buok tanan? 1,320. That's 60% of our total number of records. So, mo ni mga random numbers na iyang gihatag. 912, 1,307, 2,067, and so on. Okay? This is randomly generated. And this is a total of 1,320. So those are our index. The index of our training data. Okay, sa index lang na siya. Sunod, the next code is we have, asa na to ang kopya. Is to actually create na our training data set. Okay? Di ba tungaon man nato ng atong data set sa 60% for training and then 40% for the validation or testing. So, to actually create our training set, we have the code train.df. Wala na, unsa man ni akong gi-record diri floor away. Ay, okay ra di ay. Train.df and then delays.df. Then we have to specify here train.index and selected var. Selected that var. So we are creating here a new data train.df, and then this is to create that data. We'll have to get it from our delays.df, katong entire data set nato, and then we'll just get those data that are equivalent in our train.index, and we'll also get the selected var. Okay, so again, if we look at ako saning i-enter, if you look at train index, kato ni siyang atong gibuhat kaganina, no, train.index. Kani siya katong random numbers. And then the selected var are those columns 10, 1, 8, 4, 2, 13. So basically, it will just create a data frame based on the index, and it will get their values in these columns, in the specified columns. These are the days of the week, the CRS departure time, the origin or departure, and the flight status. So, iyahang na siyang isumpay. So, nana siya records and columns. Okay? So, kibali kini sila ang mga index. These are our index. And then, butangan na siya og columns. Okay? This is the train.index. Then, it will combine the columns specified in the selected var. So, if you look at the train.df, let's see the values inside the train.df. So, mo na ni siya. These are the index kaning naa sa pinakakilid. Okay, these are the values of the train.index. And then the values of the selected var. This is the column 10, day, week. This is column 1. This is column 8, 4, 2, and then 13. So, it now makes a new data frame. This is randomly selected, 60%. This is how you get the random records that is 60% of your total data set. And then, of course, ang nabilin, moto siyang ato ang himuon na validation. So, to get the remaining data set that are not included in your training data set, you will have to simply use the negative sign of the train.index. So that is, let's name this, the validation set, we'll name this as valid.df. And then, this will also again come from our dataset delays.df. Then you just have to specify the negative sign here, train.index. So this will get those numbers or index that are not included in the train.index. So, kung unsa tong wala na apil diri as a random number sa 60%, mo to sila ang mabutang sa 40% sa validation dataset. And then again, sumpayan siya og mga columns for selected, specified in our selected var data. So let's take a look at the valid df. So these are the index that were not selected in the 60%. Index 2, index 3, index 4, 9, 13, and they are a total of 881. This is 40% of 2,201. This is the 40%. Again, train.df is 60% randomly generated records from our delays.df. And then the valid df is 40% of the record from delays.df. Then, to run the naive base now, we now have the 60%. So, ang 60% ang atong i-calculate for their conditional probabilities in our naive base classifier. So, that is, to run now our naive base to calculate the probabilities for each variables, you'll have to use the delays.nb. This is again a new data, and then it will be coming from the naive base function. And in our naive base function, we'll have to specify this will be our the variable, the final output. Okay. The variable that we want to predict, that is the last variable, which is the flight status, because the flight status holds the on time or delayed. That's what we are gonna predict to, or we want to classify. So the flight status, then the second argument will be from the train.df. So our data in our naive Bayes will be coming from the train.df. So if you use the naive Bayes function, you'll have to specify the outcome variable. Mao ni siya ang atong gina-predict, and then the data. So our data is coming from the 60% of the data set. Okay, so mo na ni siya ang mag-hold karon, si delays.nb ang mag-hold na karon sa ato ang conditional probabilities. The result of this function is the computation of those conditional probabilities that we manually computed in our previous example using 10 records. So here we'll have we can display the conditional probabilities that is stored in delays.nb using this command. We simply print here. This command will simply print delays.nb, or the data of delays.nb. So it will give us this output. So the naive Bayes function gives us the a priori probabilities, the pivot table. So there is 18.6% of the 60% selected, or 18.6% in our training data set is delayed, and 81% is on time. Okay, so meaning there are 18.6% record of the records in our training data set whose flight status is delayed. Otherwise, it's 81.36%. And the calculation of the conditional probabilities are the following. So, automatic na siya calculate. The delayed probability, if the day of the week is 1, so it is 20.32% or 33%, or 0.20. And then you have, for if the day is Tuesday, the delayed or the conditional probability of delayed is 0.13. If Wednesday, 0.12. If Thursday, 0.13, and so on. This is for Friday, Saturday, and Sunday. And then for on time, calculate pud niya ang mga conditional probabilities for each day. Kana siya. 5, 6, 7 for on time. Next, for each CRS departure time, if the departure time is 6 o'clock, so the probability for delayed is this. For 6 o'clock, 7, 8, 9, 10, 11, 12, 13. And then for on time, this and that. And so on for on time. So for each value of the CRS departure time, so ihan ang gi-compute automatically. Maybe in your data mining subject before, while I was teaching the data mining, I have to assign my students to calculate each one of this manually. na siya sa data mining. And then here, we already have this for departure time up to 21. This is, ang sama ng 21? 9 o'clock or yeah, 9. Then for each origin, then for each destination, and for each carrier. So there are 8 carriers, and those are their conditional probabilities. Next is we have to compute now or if you want to print the conditional probability of a specific variable, we will be using this command. Prop table. So here we specify the specific this first the flight status, which is the outcome that we want to predict, and then the train.df is the specific column or variable that we want to see its conditional probabilities. So this is the conditional probability for the destination EWR, JFK, and LGA for delayed and on time. Okay. Next is we'll have the scoring of the example flight or the probability and their class. Now we want to know now the prediction for our validation set. So diri sa training set, i-calculate pa lang niya ang mga probabilities, i-identify niya ang mga probabilities for each variable. Now using these probabilities, we will be predicting the outcome or the flight status for each record in our validation set. Okay? So for example, this one, assuming balik ta sa atong Jamboard kay daghan kayo ni siya. Balik ta dito sa gamay lang. Ang saan man ipagkuan. So assuming 10 records, and then we have selected 60%, assuming this 60%, no, randomly, this is the training set, 1 2 3 4 5 6, and the validation set are 1 2 3 4. So assuming that the records here in red are the training set, and then in blue are in the validation set. So in the validation sets, we will now predict their status. Okay, we don't know yet their status, but because we already get the probabilities of this or the conditional probabilities of these variables using the training set, we can then apply those probabilities here to predict the value of the flight status of our validation set. We will be predicting the values of the flight status of our validation set. And to get that, you'll have to use the predict function. So we actually also have a formula for that manually, but we will be using here since we are using tools here. So we'll just use the function predict, and we'll have to specify our the result of our probabilities or of our naive Bayes that is stored in delays.nb, and then you'll have to specify the new data. The new data is our validation set, and then the type is equals row, so that it will compute for the probabilities for each record of our validation set. Okay, if you look at the the result of the prediction probability, this is the result. For the first record in the validation set, this is their probabilities. Probability calculated using the naive Bayes. So for delayed and on time, for each of those 881 entries, those are the number of records in our validation data set. And then, so for example, the first record will have the most probable is it is on time. Okay, because on time is 83%, delayed is 17%, so it is probable that this record will have a flight status of on time. The second record, however, is also on time. The third record also is on time, and so on. Diri, kung asa ang pinaka dako nga value mo to siya ang iyahang prediction result. Next is we have the class. To show the actual class, not the probabilities, ang class na jud na iyahang prediction result, whether it's delayed or on time, ang iyahan yung result is delayed, yung istorya is delayed or on time. Dili na tong probability numbers or result calculation. Then you'll have to use again the predict function, and we'll store the classes, the result, into pred.class. Predict So here we use the pred.class. This is our new storage name, and it will get its data from the result of the prediction, but this time it will have the result from, the type is not raw, so meaning it will give us the class, the predicted class. And the classes are whether it's delayed or on time. However, there is an error here. I think I have to repeat the code. Since the flight status is I'll have to check first the code because there is an error in the code provided by the book. So there may be an update in R that's not yet not also updated by the book. Okay, so let's go back to our code. So since we forgot to factor our flight status, we can use this as a fixed. So we'll have to factor the flight status here. So we have to use this to factor our flight status. So as factor and then flight status. Then mao lang ni siya atong giusab sa naive base sa butang taog as factor, and then we can now use the predict for the pred class. So it will now give us the prediction whether it's on time. Okay? Ang kaganina, ang pred prob gives us the probability values for each record. And there are 881 records. In the pred class, it will give us the class itself. Okay? Let's view the pred class. So, sa pred class, ang ihanag yung prediction. Okay? So, record 1, ang ihang flight status, it's predicted to be on time. Record 2, predicted class is on time. And so on. Okay, so there for example, record 99, predicted class is delayed. So, muna na siya iyang class result. Okay, pred prob for the probabilities, and then pred that class is for the class prediction class. Let's proceed to the next one. Kamo na mag-try ani, wala na ni siya error. So diri ang sunod is mao na ni siya. Ang sunod niya is maghimo siya og data frame. This is a new data frame, and it will give us the actual flight status and the predicted class, and then the predicted probabilities. So it will just compute each of the records, and it will show the actual flight status and then the actual status compared to the predicted. Di ba ang validation dataset na amang gito sila yung mga flight status. Tapos, i-show pod niya unsa ang iyahang prediction. Okay? Compare niya ang tinuod niya nga flight status and ang prediction. Mo ni ang result sa data frame DF. And then, it will also show the conditional probabilities. Next is you have the DF. This one is you will give specific data for each variable. Sa carrier, what if the carrier is DL? What if the day week is 7? What if the CRS departure time is 10? And the destination is LGA and the origin is DCA. Unsa ang iyahang flight status? Mao na ni siya karon ang application of the prediction. So, given this code, it will give us a value of whether it's on time or if it's delayed. Okay? So, given this data, it will give us a prediction of delayed or on time. So, this will be the output. It will have the actual. So, since this data is in the data or in the validation data set, its actual value is on time. ang gipredict niya is on time. Ang prediction niya is on time. So, mo ni ang probabilities niya. Delayed is 0.06 and on time is 0.94. So, the result is on time. And another record in record number 700. So maybe in your result maglahi ni siya kay random man, di ba? Random man atong validation og ang atong training. So pwede nga malahi ning ilahang mga index. So here, the result for record number 700, its probability is higher for the class on time. So, yung predicted is on time. If we compare it to its actual value on time, the prediction is correct. So we also have, after scoring, we usually have after classification, your classification, you need to evaluate the performance of your classification model, and you will have to use a confusion matrix for that. So to create a confusion matrix, you will need to use the library caret, and then this will be creating a confusion matrix for the training set. So you will just have to create the prediction class, just what we did in the validation class or validation set. So we predict the classes, but this one is we use the training data set. Kaganina is validation data set ang atong gi-predict ang class. So gi-predict na to tanan record sa training set, and then illustrate siya og confusion matrix. So ang result ani is mao ni. Okay, sa training set. So pasabot aning sa confusion matrix, makita nato ang accuracy ba sa ato ang classification task or classification model. So this means that sa training data set, delayed, there are 30 actual delayed na predict niya as delayed. So correct iyang prediction sa 30 ka book delayed. But there are 39 on time but predicted as delayed. And there are 230 delayed predicted as on time. And then there are 1,021 on time predicted as on time. So these are correct on time and these are correct delayed. These are the incorrect predictions. Ang 39 and 230 are the incorrect predictions. If you compute this manually, this is 79.6% accuracy. So this means that the classification model is 79.6% accurate based on your training data set. Pagkahuman sa validation data set, pareha lang ni kaganina pero nag-add siya og confusion matrix. So, iyang gi-print diri ang confusion matrix, and ang iyahang accuracy sa validation data set is 80.5%. So, if we use a manual calculation, the correct prediction is here in the training set. The correct prediction is 30 plus 1021 equals 1,051 records out of asa man ang parenthesis ani, out of 1,000, pila ni siya ka records tanan, 1,051 plus 39 plus 230. So this is 10 ako 1021 ay no 1021 plus 30, so 1051 correct predictions, and the total number of data in the training set is 1051 plus 39 plus 230. Okay, so that is 1,320 tanan ang naasa training. This is in the training dataset. That's a total of 1,320. So out of 1,320 records, there are only 1,051 correct predictions. So ang accuracy niya is 79.6% sa training dataset. So the same calculation sa validation dataset. So that's how we perform evaluation of our classifier using the confusion matrix. So that's it. That's pretty all for this afternoon. Do you have questions? Lahi na nga file name, no? Pero the same, pareha lang dito ra gyapon na link. Flight delays. Sige sa. By the way, ang file name aning atong gigamit na dataset is flight delays. So, it's already 3:29 na daw mo meeting kang Sir Rafi. So, we will end na our meeting. If you have questions or clarifications, so you can just message me through GC or PM. Okay, so that's it for this afternoon. Thank you for your time. Thanks for
Thank you, ma'am.
attending.
Thank you, ma'am.
Okay, see you next meeting. That will be the week after next week. Okay, thank you
Ma'am.
very much. Bye bye, guys.
Bye. Thank you.